Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
In this problem, we have a parallel plate capacitor that has square plates, and a current is passing through, producing a uniform electric field between the plates, with the electric field perpendicular to the plate. And we want to know what is the displacement current that is passing through the capacitor for part A. The electric field between the plates is parallel in a parallel plate capacitor is charging, so there is a non-zero displacement current that is proportional to the variation of the electric flux. So ID is epsilon zero d phi e dt. Let A be the area of the plate and E be the magnitude of the electric field. The electric field between the plates is uniform, so we have that E is V over D, V being the potential, and D is the separation between the plates. So we have that I, the current into the capacitor, being dq dt, and we can write this as dCV dt, and this can be written as epsilon zero A divided by d ed dt, and we can write this as epsilon zero d phi e dt, which is the same as the displacement current. So the current inside the capacitor is the same as the displacement current. So at any instant, the displacement current in the gap between the plates is equal to the conductor current in the wires. So we have that for part A, ID is equal to I is equal to 2.08 amperes. For part B, we want to know what is the variation of the electric field in this ratio. So for part B, we have that dE dt is equal to the displacement current divided by epsilon zero A, and this is 2 divided by 8.85 times 10 to the minus 12 times 1 square, everything in meters. This is 2.3 times 10 to the 11 volts by meter second. For part C, we want to know what is the displacement current encircled by the square dashed path of edge of 0.5. So we have for part C, the displacement current prime is the displacement current times the ratio between the curved path and the total length. And this is 2 times 0.5 divided by 1 square. This is 0.5 amperes. For part D, we want to know what is the value of BDS around the square dash path. And we have that integral of BDS is mu0 I d prime. So this is 1.26 times 10 to the minus 16 times 0.5, and this gives 6.3 times 10 to the minus 7 Tesla meters.